Hello, my name's Joanna and you're with Miss Buckle Maths. I've designed a lesson to take you through everything you need for straight line graphs on the foundation paper. Now it's highlighted here, we're going to do drawing graphs, we're going to do finding the gradient and intercept from a graph and how we apply that to y equals mx plus c, and writing the equation when you are given the gradient and the intercept. So this is to cover the parts that are needed up to a grade 5. If it's useful to you, please like, share, follow along, and there's more in this series for you to see. Okay, so let's start with drawing graphs. Now, so when you're given a table of values, we have to be able to complete the table of values and draw the graph from it. Now view this equation as your set of instructions. The y coordinate is equal to 4 times the x coordinate, and we're subtracting 4 from it. So that stands for the y coordinate and the x coordinate. So we have to find the different values of y for our values of x. So when x is equal to 3, always start with the positive end first. We're doing 4 times by 3. So I'm just substituting the value of 3 in place of the x. Take away 4. 4 times 3 is 12. 12 subtract 4 is 8. So when x is 3, y is equal to 8. And that's our first coordinate. When x is 3, y is 8. And you can plot that straight onto your graph. And we do the same for each value of x. So the next one, when x is equal to 2, we're doing 4 times 2. 4 times 2 is 8. 8 take away 4 is 4. So 2, 4 would be another coordinate. When x is 2, y is equal to 4. When x is 1, y is equal to 4 times 1 is 4. 4 take away 4 is 0. And we keep going. Now I'd start to advise students to look for the pattern. If we're doing a linear sequence, we can see the pattern, and we're going down by 4 each time. So our remaining terms are going to be negative 4, negative 8, negative 12, and you will see that they will form a nice straight line if you've got the correct coordinates there. Now join these up with a straight line, okay? So there we go, there's our graph. So that is y is equal to, the y coordinate is equal to 4 lots of the x coordinate, subtract 4 from it. Okay, a really similar one, but this time just be careful with your substitution here, and they've given you a couple of values. Look, they've told you that when x is 2, y is equal to negative 3, so that's a coordinate, 2, negative 3. And they've also told you when x is negative 1, y is equal to 3. When x is negative 1, y is equal to 3. Now that would actually be enough to plot the graph. I mean, you can see where you're going to find these missing values here, and that's a bit of a hint. But let's continue it. So the y coordinate is equal to 1 subtract 2 times the x coordinate. So let's just do when x is equal to 3. We are doing y coordinate is equal to 1 subtract 2 times 3, which is 1 subtract 6. 1 take away 6 is minus 5. So when x is 3, y is negative 5. When x is 3, y is negative 5. Okay, when x is 1, we're doing 1 take away 2 times 1, which is 2. 1 take away 2 is negative 1. 1 take away 0 is 1. And we can follow the pattern. That's going to be 5. It's going up by 2 each time. Okay, so filling in your missing coordinates, negative 2, 5, and drawing a straight line means that we now have our graph of y is equal to 1 subtract 2x. Okay, there you go. So that's completing a table of values and plotting the graph based on that. Now, they also present questions without the table of values. So it just says on the grid, draw the graph of y equals 2x minus 3. Now, there's a few ways of doing this. You can do it without the table, but it's a good method to use if you're confident with it. Now it tells you what values it wants x to be. So it wants x between negative 3 to 3. So you need to create your table of values for x to go between negative 3 and 3. And then you can complete it in the same way. So the y coordinate is equal to 2 times the x coordinate, subtract 3. Substitute in your different values for x. So start when x is equal to 3. Y is 2 times by 3, subtract 3, 6 take away 3. So when x is 3, y is 3, and there is your first coordinate. When x is 2, we're doing 4, take away 3 is 1, so x is 2, y is 1. When x is 1, 2 times 1 is 2, 2 take away 3 is negative 1. And you can see it's going down by 2 each time. So negative 3, negative 5, negative 7, and negative 9. I haven't done my I haven't showed enough of my screen for that, but you would just complete it and just carry it on. Okay, so there we go. That is the graph of y is equal to 2x minus 3. So without the table of values, draw your own table of values together. Sometimes they might show it as an inequality. So x values are greater than or equal to negative 3, but less than or equal to 3. But that's how you then do your own table. Okay, then the slightly different type, this one here, but once again, just see these as a set of instructions. It's telling you that the x coordinate plus the y coordinate is equal to 3. The x coordinate plus the y coordinate is equal to 3, and it wants it for x values between negative 1 to 5. X values from negative 1 to 5. So x negative 1, 0, 1, 2, 3, 4, 5. And we're trying to find out what the y values would be. So the two have to add together to make 3. I'm just going to start when x is 0. Well, if x is 0, 0 plus 3 make 3. So when x is 0, y is 3. When x is 1, y must be 2 because 1 plus 2 makes 3. When x is 2, y is 1. Etc. Okay, and you can continue on your table. Once again, you're going to see that it's going to be a straight line, and if it's not a straight line, then there's been an issue, an error in working that, so just go back and check your working. Okay, right. So how do we find the gradient in the centre? What am I even going on about? So the general equation of a straight line is y equals mx plus c. That is your general equation for a straight line. Y equals mx plus c. Now, the m stands for something very specific, which is the gradient, and the c stands for the where it crosses the y-axis, which is the y-intercept. So let's go about how we'd find the equation of this line based on y equals mx plus c. So let's start with the c, which is where it crosses the y-axis, because that I feel is the most obvious. So this one crosses the y-axis at 3. So we know it's going to be y equals mx plus 3. Okay, so I'm going to replace that c with the number 3. Right. The y is always there, the x is always there, it's just now the m, the gradient we have to find. Now, this is sometimes called changing y over changing x, or the rise over run. Basically, you're looking at how much it goes up for every 1 it goes across. So, and I'll just explain that in full. So it's going from 1 to 2 in x, and it's gone up 2 in y. So the change in y, or how much it's risen, has gone across by 2. How much it's gone across is 1. The run is 1. The change in x is 1. 2 divided by 1 is equal to 2. So that value there is 2. The gradient is 2. Okay. Now you can work this out in a number of ways. Let's say we picked this point to this point here. Now this time the run is 3. And the rise is equal to, but it's gone from 3 to 9. So the rise is equal to 6. But rise divided by run again, 6 divided by 3 would still be 2. It would still give you that value of 2. So there's a number of ways of doing that. But the equation of this line would be y equals 2x plus 3. Okay, on to another one here. So remember, the m is equal to the rise over run. Okay, so let's do a run of 2. Look, it's gone across 2. And now it's going down 6. from 5 to -1 is going down 6. So the rise is -6, the run is 2, therefore the gradient is -3. C, the y-intercept, where does it cross the y-axis? It crosses the y-axis at -1. So that would be y equals, because remember it's always in the form y equals mx plus c. M is -3, so y equals -3x, with c at the end being -1. Okay, right, this one here. M is the rise over run. Let's pick 2 points. I'm going to pick that point there and that point there, those 2 coordinates. So the run is equal to 2. It's gone from 0 to 2. Be careful of your axes. And it's risen by 2. So rise was 2, the run was 2, so my gradient is 1. C, the value where it crosses the y-axis is +1. So it would be y equals 1x, or just x, plus 1. Y equals mx plus c. That was a 1 in front of the x for the gradient because it was 2 across from 0 to 2 and 2 up. And the y-intercept was 1. Right, this one here. So your gradient, your rise over run, let's pick a couple of points. It's going across from -1 to 1, so that's across 2. The run is 2, and it's going up to the value 9. So it's going up from 3 to 9, which is 6. So the run was 2, the rise was 6. Rise over run, 6 over 2, which was 3. So the gradient is 3, and the y-intercept, what value does that graph cross the y-axis? It's 6. So remember, a straight line graph is y equals mx plus c, so it's y equals 3x plus 6. Okay, right, you're often asked for the equation of a line that is parallel to a particular line, so a line that is parallel. Now, if you're asked for that, now the thing about parallel lines is they have the same steepness as each other. And other than that, doesn't really matter. So it doesn't matter where it crosses the y-axis. So this blue line that is parallel to our line crosses the y-axis at 3, but it could cross at 1, 0, -1, -2, etc. Doesn't matter. Parallel lines have to have the same gradient, okay? So parallel lines have the same gradient. So a line that is parallel to y equals 3x plus 6 would be y equals 3x plus any number, right? It could be a negative number, it could be a positive number. I'm going to put plus 100, it doesn't matter. The only point that matters is that they have the same gradient, okay? Right, if you're just given the equation, you're told to write down the equation and you're just given the gradient and the y-intercept, you can just substitute those values in. Y equals 4x plus 1, just remembering that it's y equals mx plus c, and that the m is the gradient and that c is the y-intercept, and that's the tools you need, okay? So y equals -2x plus 5. Okay, and then there's this type where they don't explicitly give you the y-intercept, but they're told what you're given the point that it crosses the y-axis. If we think about anything with an x-coordinate of 0, that is the point on the y-axis where it crosses. So the gradient is 2. Remember, y equals mx plus c. We're told the gradient is 2, so y equals 2x, and it is literally a case of whatever number there. If that's a 0, because it's on the y-axis, then you can just put the other value in the y-coordinate there. That's another 0 there. Look, a gradient of 3, so y equals 3x plus 5. Okay then, just to finish off, a couple more. Find the equation of the lines. Always start by writing y equals mx plus c. M is the gradient, the rise over run. So pick 2 points on the line. I'm going to pick those 2. The run is 2. The rise is -4. So the gradient is -2. The c value, where does it cross the y-axis? In this case is 5. So my equation would be y equals negative 2x plus 5. This one, let's do a run of 1, a rise of 2. So when it's in the form y equals mx plus c, the gradient is equal to the rise over run, which would be 2 risen, 1 across. 2 over 1 is 2. The c is where it crosses the y-axis at 3. So y equals 2x plus 3. Okay, so I guess the last thing to consider here is when it gives you an equation and it asks you to state the y-intercept, or it asks you to state the gradient. So for example, say they say y equals 3x minus 2 and it asks for the y-intercept. Okay, you would write down the y-intercept is 0, negative 2. The coordinates of the y-intercept is 0, negative 2. And you can read that directly from it. X is 0 obviously on the y-axis and the y is negative 2. However, sometimes they might give it in this different form. They might say 2y is equal to 6x minus 4. What is the y-intercept? Now, you can only read off the y-intercept when it is in the form a singular y is equal to mx plus c. That is when you can see from the equation what the gradient in the y-intercept was. So you would have to start by dividing through by 2 before you then answered your question. Okay, if this has helped, please give it a thumbs up. Any comments are appreciated, and a follow, and I'll complete some more in the series of a mini series of what you need to know for each topic on your Maths GCSE. See you in the next video.